Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled a CNN and FFANN-Based approach for heart disease detection. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the work that we have done in the medical domain by using the artificial intelligence. So this is related to the signal processing also. So let's talk about the video. So before going to the video, let's talk about that what we will cover into this video. In this video, we will initially talk about whatever the application we have designed for by using the artificial intelligence for signal handling like ECG. In which application areas it can be implemented. Then we will talk about what exactly the code we have designed, which files you need to execute, and what are the software requirements to execute the code. Then we will discuss about the current systems, those are currently working into the same domain, and what exactly they are doing, what problems we have identified in the current systems, and how proposed system is able to handle that. Finally, we will cover the experimental outcomes and the results, and also show the comparison that how our proposed system is better in comparison to the other state-of-art methods. So let's talk about the application areas. The application area that we are covering by using this is related to the biomedical applications, where the AI is playing an important role in detecting the health of the patient. So the system is related to the medical healthcare systems. It shows the role of the AI in the healthcare, and for many of the biomedical applications for identifying the disease in the patient on time, so that the doctors can take the appropriate step and to automate the process of detection. It is done under this category. So let's talk about the code. We will provide you the folder, this under the code folder we do have all the files. The whole code is written in the MATLAB, so you must have the MATLAB software with you. So the MATLAB version that I am using is R2019A. So you can use 2018 or 2019 or above, but make sure the MATLAB version that you are using must be of full version, not the trial one. So in order to run the code, you just need to copy the path of the code where the whole code and the database is being saved, and then go to the MATLAB and you just need to paste it here. When you will paste, Ctrl V, press enter, you can see it can directly redirect to the main code. So here main code is the file that you need to execute. Rest all are the files, those function files, those are called in the main file. Now in order to run this code, you just need to click on the run button and it start executing. So here in the editor section there is a run button and you just need to click on the run. So I'm just copying it because I need to discuss it later on. So I'm just going to click on the run button. So you can see it start processing the code. These are the ECG signals that it is reading from the database and all. So in the meantime it is running, let's talk about the problem and the current systems. So the base paper that we have considered for the proposed system is like ECG, automatic ECG diagnosis using the convolutional neural network, which is also known as CNN. So they have implemented the ECG signal and passing the whole signal directly to the CNN, and on that behalf they are evaluating that of what state it is. So the crucial for this particular model was that they were using that CNN model is specifically designed for the image related data, not for the signal one of the issue that we identified. Secondly, they are passing the signal directly instead working with the information that is under it, because working with the deep learning is only then effective when you have only refined data, precise data, where the information cannot be easily extracted. But the literature shows in such domains machine learning is very much beneficial. Only the challenge with the machine learning was they were not able to handle the larger data set. Their deep learning can be efficiently processed. So we can't neglect the power of the machine learning. So here what we are doing, because the data set on which they were working, that was not the bigger one. They have used the 47 subjects data and giving us the outcomes for the different. So let's talk about the data set. Before that, let's talk about what we have done in our the proposed system. We have changed the CNN system, and in combination with the CNN, we are using the machine learning's feed forward neural network. So we are combining the power of machine learning and the deep learning in order to identify the ECG diagnosis, so that we can identify which class the person or the patient is suffering from, which class, whether it is normal or what. So there are total of the three classes. One is the normal class, another one artery premature beat, and third one is one more. So they have used only for the two classes, but we have worked for all the three classes. So let's talk about the data set. The data set they were using is the MIT BIH database, which can be taken from the physionet or kaggle.com. So this is the link that you can use to get the database. So you can directly download it from here. There are certain options to download it. So you can download it in a zip file, or you can directly copy one individual file in the dat files. So we were using the dat files with us. So this data set is downloaded and saved in the folder under which the whole code is there. Here you can see all the files from the database are saved here. So we are using this one. So in the proposed work, what we have done, the simulation is completed. Let's talk about what we have done. In the initial stage, the database is being processed, and we do have the three categories of labels. Those were like normal, artery premature beat, and premature ventricular contraction. So let's make the comment here also, so that later on it can easily be seen and can be known. So I just made the comments. So these are the three categories labels of the data set. So initially we are reading the data. We are not passing it directly to the CNN. We are doing some pre-processing phases, because the signal that is captured from the device, they might have some issues with them, some noise with them. So we are pre-processing it. So initially, whatever the signal we do have, we are normalizing it. After normalizing, we are applying the filtration process, under which we are applying the median filtration for multiple times. After applying the Windows based process, then we are calculating the features in terms of the like mean, variance, entropy. Then we are detecting R to R signal from the ECG, because ECG is having the information like ECG signal. So you can see the ECG signal is having the information of PQRS, and R to R variation shows us more information that what is the variation among, and whether the person is affected from any of the heart issues or not. So R to R detection is mandatory. So after that, we are calculating few more, like number of R peaks in that sample, mean of the heart rate, standard deviation, and the frequency coefficients. We are combining all the features and put it into the single variable. Why we are doing this? Because this information can assist the models to get more precise information instead of processing the whole information. And also, as we are using the machine learning, so it will be beneficial for that also. Then we have created that data set and passed it to the two models. One of the model is the CNN model that we have designed. Second model is the so we are training the model by using the CNN and getting the predicted outcome from them. Second option, we are using the feed forward neural network, in that is the type of the ANN, artificial neural network, and machine learning. So we are training it, and after training we are getting the better the final outcomes. Then we are combining the outcomes of the CNN and the feed forward by the weight based, in which the weightage 0.8 weightage is given to the deep learning, and 0.2 weightage is given to the feed forward neural network. Why? Because deep learning is obviously more capable of training the patterns, but machine learning is also good. So we are combining the power of both. And what we realized, the outcomes that we have analyzed in the terms of the accuracy, TPR, true positive rate, true negative rate, false positive rate, false negative rate, and F1 score. So all these parameters has been calculated, because we need to compare it with the base paper. They have evaluated the same parameters. Here you can see. So let's see what we got and what are the results. So the results that we got are like this. This is the original signal. This is the normalized signal. So you can see the actual signal is normalized within a range of 0 to 1. Then we have calculated the features like baseline signal from that. This is the coefficients that we have calculated from the DWT, and these are the detailed information that we have extracted from it. Then These are the performance parameter of accuracy, TPR, TNR, FPR, FDR, and F1 score of the proposed method only. This is the confusion matrix for the three classes. This the percentage of the parameter in terms of the percentage, where we are doing the comparison with the base model of the CNN, which is the base papers model. Then we have compared step by step with the accuracy, TPR, FPR, and all the parameters. So you can see in every scenario, our proposed method is proving its effectiveness in comparison to the traditional method and shows the better results. Here the tabular form of the parameters is also shown for the base paper CNN and the proposed CNN feed forward neural network. So this gives us the better outcomes. If it will be rerun again and again, you can see even more accuracy can be achieved, and more outcomes can be achieved in the same scenario. So these are the real-term scenarios where you just need to give directly the ECG signal to the machine. The trained model will be able to detect that whether the person is normal, it is having the premature beat, or the ventricular contractions. So if you will know it on time, you can easily save the person, or the patient can save himself herself by taking the appropriate medicines or the help from the doctor. So real-time scenarios and further modifications are possible. The researchers or the industry people can contact us directly to get the information. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.